In this video, we want to work on some 8 important ideas and 6 homeworks, and we will solve BMO 1 2022, 2023, and 2021, 2022. Also, we will solve related IMO problems and we will leave homework from IMO problems and other exams. Okay, so we will solve here which problem? Problem number 5 from last BMO 1, and we work on considering small example important structure that is also useful in SUMAC, Stanford summer camp, and 3 important ideas in paths that you should learn, and also useful in BMO other years of BMO. If you want to learn, there are around 40-50 important formulas and ideas. If you want to learn them, feel free to send message to my WhatsApp number in the description and comments. And from BMO 1 2021, we will solve problem number 3, and I will teach you how to work with recursive sequences problem and represents what important question. And we will solve this problem. We will solve IMO problem with exactly same idea. It was for 2013 or 2014. And then also at the end, you can solve this IMO problem, IMO 2019 part B. Part A is related to invariant. Invariant also useful in BMO 2 2023 and some BMO 1 problems. There are 3 main techniques in invariant. If you want to learn them or want to learn the other ideas, want to have more problems, feel free to send message to my WhatsApp number in the description and comments. Part B is related to the BMO problems. You can solve this part as homework. Okay, let's start. Okay, BMO 1 2022, last BMO. Here we have how many problems? 6 problems. Okay, so let's work on problem 5 here. For each integer n at least one, let f of n be the number of lists of different positive integers starting with 1 and ending with n, in which each term except the last divides its successor. And prove that for each integer n greater than or equal 1, there is an integer small n greater than or equal 1 such that big N divides f of small n. F of 1, so let's see. F of 1 is 1 because it's this. F of 2, you have 1, 2. F of 6, you can say 1, 6 or 1, 2, 6, or we can say 1, 3, 6 because each term should divide next term. We have these 3 terms. Okay, so first idea that I can say in all years of BMO 1 and also BMO 2 useful is considering small examples, okay, to find the idea, not only find the pattern. Considering small examples. And try to see, okay, and then generalize it step by step. So here, for example, a small example we can consider on idea 2. We can consider structure, special structure of a number is what by this structure prime factorization. Okay, it is also useful in SUMAC 2022 and in many other problems. AMC 10, homework 1, homework 2, AMC 10, 12 problems. We have similar problems that you can solve with this. And as I said, there are around 40-50 important formulas. If you want to know them and exactly the homeworks are what, SUMAC is what for Stanford summer camp, okay? They release some problems and you should solve. And AMC is what for American mathematics competition. Now, let me explain for you here is what. We want to say f of prime is what? F of prime is what? 1, next one is p, is 1. Then I want to find, for example, f of p to the power of alpha is what? So let's consider, for example, p squared. It is 1 p squared or 1 p squared. So it is what? It is 2. Now we can consider f of, for example, p cubed. So you say 1, first one, last one, p squared, we should have them. Sorry, here is p cubed. Then you can have p or p, you can have p or we can ignore it, or p squared. We have 2 cases, okay? Any options for them will be good. So 2 times 2, 4, 2 squared. So f of p to the k is what then by this option? Try to find it on your own. You can say like this. 1, we should have 1 p to the k, but for p we have two options. For p squared we have two options. For p to the k minus 1 we have two options. It is what? 2 to the k minus 1. Okay? Now we will see we cannot cover because this for every n prove that there's an integer such that n divides f of n, small n. So here we proved only for when we want to say n f of, for example, n. For powers of 2, we could prove it. Okay? Now, second step, exactly like summing, prime factorization. Now we consider two primes. Okay? So f of pq is what? Then we want to consider f of pq squared is what? Then we want to consider f of pq cubed is what? Okay, we consider first power, and then at the end we want to find f of p q to the k is what? Try this part first on your own. Okay, f of pq is what? We can say, okay, 1 pq, 1 ppq, 1 qpq, okay? We have only these three terms. If we consider pq squared, let's consider a structure. For example, for this part, you say, okay, we have two directions. Okay, one, P, here, Q, here it is PQ. We can go like this, or this part, or this part, or this part, this part, three ways. Okay, for next part, if we do the same thing, it will be like this. 1 Q squared is P, so this number will be PQ. This number will be PQ squared. So you can go, for example, on 1, you can go like this, okay? So let me tell you an idea. It is related to paths. So we have three ideas in paths. Okay, okay, so idea 3 related to paths, but the idea is what number? Okay, we have two more ideas for paths. One of them is permutation and one of them levels. And also those ideas are important. Here we need only numbering, and I will tell you completely this idea is what? It has two steps. Okay, if you want to learn, there are, as I said, 40, 50 important formulas in each topics that are useful for BMO. Feel free to send message to my WhatsApp number in the description comments. For this idea, you should say origin is 1 and number of each position equal to sum of the numbers of exactly previous position. Why? Let me explain for you. Previous position. Okay. It means what? Suppose we have, for example, a school in a street. If we can reach from with For example, 2 ways here, 3 ways here. And how many ways can we reach to this school? 5 ways, because you say, okay, 1, 2, 3, 4, 5. Okay. It is exactly this idea. You say, okay, when I'm in the school in previous step, exactly previous step, I was here or here. And then 2 plus 3, 5. Okay. Or if you have a dead end, for example, a school here, in 3 ways we can reach here. In how many ways we can reach this school? 3 ways. Now let's apply here. You say, okay, I know that, for example, from here, I can go here, I can go here in this direction, right or up or right and up. Now, if I want to use numbering here, I say, okay, origin is 1, first step. And then if I reach this to this part, previous step, I was here, 1 way. If I reach this part, in previous step, I was here or here, 1 plus 1, 2. If I reach here, in previous step, I was here, 1. If I reach here, in previous step, I was here, 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 1 plus 1 plus 1, 3. If I was here, it's 3 plus 1 plus this plus this plus this. It's 2 plus 1, 3. 3 plus 1, 4. 4 plus 1, 5. 5 plus 3, 8. Okay, so let's check it to see is the answer 8 or not, or PQ squared. So you say 1, the next one is P, or the next one is Q, or next one is Q squared, or next one is PQ, or next one is PQ squared. Here it was finished, here it is only PQ squared, so 2 cases for Q squared. Next one should be what? Next one again should be PQ squared, 3 cases. Now let's consider P and Q. If it is P, next one can be PQ or PQ squared, so 2 cases. Okay. If it is Q, so in next step, let me also show you if it is PQ, here next one should be PQ squared, okay? 1, 2, 3, 4, 5 cases. If it is Q, next case can be Q squared, next case can be PQ, next case can be PQ squared, okay? Only these cases. And here it will be again one other case for Q squared. Next one should be PQ squared. For this one, next case should be PQ squared. So 1, 2, 3, 4, 5, 6, 7, 8. It will be okay. So it is 8. Now that you've learned this, see, try to find PQ cubed and then try to generalize it for PQK. The answer is what? Try, and by the idea I told you in Pathos, try first on your own. Okay, let's calculate PQ cube. It is 1, it is Q, it is Q squared, and it is Q cubed. Okay, so if you write, it is 1, 1, 1 plus 1, 2, 2 plus 1 plus 1, 4, 1, 1 plus 1 plus 1, 3, 2 plus 1, 3, 4, 5, 8. So as you can see, it is exactly like this. So when we calculate, for example, A2, for A3, we can only focus on this part. So it will be sum of all of them. We know sum of this part is 8. So 8 plus 8, 16 plus 4, 20. Now A3 is what? A3 is 20. If we continue, let's check. Here it is 8 again, because sum of all these terms equal to 8. For this point, we should calculate all of them. So it will be what? We know sum of this part equal to 20, 20, 20, 40, 40 plus 8, 48. So this one is what? Is A4. This one is A3, A2, A1, A0. Okay, 1 is 3. Now I want to find the formula. A4 is what? 2 times A3 plus 8. A3 is what? 2 times A2 plus what? Plus 4. And I told you the reason is what? Because look, A3 is sum of all of them. Exactly in previous step, they can jump here. And this one we know is 8. So it is 8 plus this one, which is 8. 8 plus 8 plus 4. 2 times 8 plus 4. And now here, for example, can you guess A5 is what? It's 2 times A4 similarly plus 16. And if you write, for example, like this, AN is what? You can say 2AN minus 1 plus 2. Here is 5 is 2 to the 4, 4 to Q, 2 to the N minus 1. Now for this case, AN, which is 2AN minus 1 plus 2 to the N minus 1. And A1 is what? A1 is 3. Or we can say A0 is 1. We want to find closed form. Okay, so I5, I6. Finding closed form. Let me tell you 3 useful things. First one is when AN equals, for example, AN minus 1 plus, for example, N plus 2. When A0, for example, is 1 or 2, something like this. It is the first structure. A2 is when we have constant coefficient like this problem, for example, 2, 3, anything like that. But minus 1, for example, plus 1, and A0, for example, is 5. Third one is when AN equals, for example, the coefficient is not constant related to N plus, for example, N minus 2 factorial, and A0 is what? A0 is 3. Now I want to tell you how we can find closed form. For the first one, you should use telescoping rule. You should write AN minus 1 equals N plus 2, and then you write AN minus 1 minus AN minus 2 equals N plus 1, and you can go up to, for example, A1 minus A0 equals N plus 2, this plus 2, 3. And when you add, you will reach AN minus A0. A0 is 2. You can replace, you can do the rest as homework 1. It is easy. And we call it telescoping rule or telescoping sum. Okay? Now, also you can, let me tell you the idea for homework 2. The idea for homework 2 is to define Bn equals An over 3 to the n. Then you can use telescoping rule. And in this problem, I will explain completely. So as homework 2, try to do rest of this. And homework 3, you should see here, we should define Bn as what, okay? And if you have had any question or couldn't solve this, wanted hint, feel free to send message to my WhatsApp number in the description comments. Okay. So, I told you the idea here. We should divide by this constant to the power of n. Now, let's try to find closed form here. Try to find closed form first on your own by applying this idea. Okay, so let's solve this one in a new page. So here I define Bn equals An over 2 to the n. Okay, now I want to use Bn, so I divide both sides by 2 to the n. It will be An over 2 to the n, 2an minus 1 over 2 to the n, plus 2n minus 1 over 2 to the n. So it will be what? It will be an over 2 to the n equals, if you divide 2 by this, it will be an minus 1 over 2 to the n minus 1 plus 1 half. Okay, and if you write like Bn equals Bn minus 1 plus 1 half. And B0 is what? Because B0 is A0 over 2 to the 0, it is A0 over 1, which is A0 is 1, so it will be 1. Now, if I will use telescoping rule, I write it as Bn minus 1 equal 1. Bn minus 1 minus Bn minus 2 equals 1 half. Up to B1 minus B0 equals 1 half. So if you add all these terms, it will be Bn minus B0 is 1 minus 1 equals how many 1 halves? N1. So it is N over 2. So Bn equals N over 2 plus 1. Now An is what? An is 2 to the n times Bn. So An equals 2 to the n times Bn, which is 2 to the n times N over 2 plus 1, which is 2 to the n times n plus 2 if you use common denominator over 2. So it will be equal to n plus 2 times 2 to the n minus 1. So let's check. By this formula, A1 is what? Is 3 times 2 to the 1 minus 1, 2 to the 0 is 3. A2 is what? Is 4 times 2 to the 2 minus 1, 4 times 2, 8. A3 should be 20. It's 5, 3 plus 2 times 2 to the 2, 20. So we will see it is correct. Okay, now by finding this, it says, okay, it is what? It was f of pq to the n equals n plus 2 times 2 to the n minus 1. It says for each big N, try to find f of something that divides that. We can say f of pq, the n minus 2, because it will be what? It will be n times 2 to the what here? This minus 3. So it will be n minus 3. Okay? And we know n divides this number. Okay, so we solve this problem by what? By considering small example first, main idea, and then this structure that for prime numbers, something like this useful. I told you homework 1 and 2 here. So this one will be 3, homework 4, homework 5. Okay, so we had 5 homework. So now let me tell you, it was a problem from BMO 1 2022. Okay, 2022, 2023. Last BMO, we solved this. So this structure of proof is repeated also in other years. Let's try. Okay, BMO 1 2021. Again, let's solve here. I released solutions of this year and also 2022, 2023. Here, let's work on, for example, problem number 3. It says what? For each integer 0, n is at least 0, n is at most 11. Elisa has exactly 3 identical pieces of gold that weigh 2 to the n grams. In how many different ways can she form a pile of gold weighing 2021 grams? Two piles are different if they contain different numbers of gold pieces of some weights. The arrangement of the pieces in the pile is relevant. Okay, so it means what? It means that we have 3 2 to the 0, means we have 3 ones, we have 3 twos, we have 3 fours, up to 3 2 to the 11. Okay, now let's try. It says we want to create 2021. Let's consider it as M. Again for this problem, like BMO 2023, we should use a small example. Okay, so what a small example that we want to use is good to use a small example on what? So I use a small example on m. M equals, for example, 1. And let's consider f of 1 is number of ways we want to create, or a1 is what you can create only with 1, it is 1. M2 is what? 1, 1, or 2, 2 ways. So try to find A3, A4 up to the case to find that you can be able to find AN in general, AM in general. Try. Okay, so here, let's calculate A3. Let me tell you something. You have an important idea. Let me see, it will be idea what? I told you 6 ideas, idea 7. In recursive sequence, also in IMO problem. Use. When you want to solve problem like this, you should say what? For example, here number of weights, something like this, or m, a variable. For example, mn, something like this here. You say n represents what? For example, here n number of, for example, different identical weights, something like this, or m. And then consider first or last of that. At first you think, okay, of the thing you've answered. You think it is an obvious question, but it is so much helpful. Here, okay, so when I want to calculate A3, I say, okay, n or from 0 to 11 number of different weights. So I consider first weight. So here, because 3 is odd, we can have how many ones because others are even. We can have 3 ones or 1 1. If you have 3 ones, it will be 1. If you have 1 1, the rest should be 2. Okay, so and the rest should be 2, and here you can only use what? You can only use 2. So 1 plus 1, 2. Now let's work on M4. M4, A4 is what? Number of ones again. We can have 0 because the 4 is even. We can have 0, 1 or 2 ones. So 2 ones, the rest sum is 2. Or 0, 1, the rest is 4. So here, because it is 2, you can only use 2. For 4, you can use 2 twos or 4. So it will be what? It will be 3. Now, so try to see, can you find, so it is 1, 2, 2, 3. Let's check. For M5, A5 is what? We can have 1, 1. Sum is 4, or we can have 3 ones. The sum is 2. If you want to create this, it is 2, 2 or 4 like this. 2 cases. For here, we can have only 2. One case 3. So now we can guess A, for example, M is what in general, and try to prove by recursive sequence. And the idea I've told you, idea 7. Try first on your own. Okay, now let me tell you rest. For M5, we've reached this. Okay, so as you can, at first AM is what? We guess M is what? So look, for 3, it is 2. 3 over 2, floor or seal of that, seal of that. So we can understand that it is M over 2, this seal of M over 2. And for 4, it is correct or not? Okay, for 4, it is wrong, but for 3, it is correct. So let's do something else. Floor of M over 2, we want to guess, then we try to prove this one. For 4, it is correct. For 3, it is correct. For 2, it is correct. For 5, it is correct. Okay, now we want to prove why it is correct. Now, here, when we have 1, 1, we should create 4. But as you can see, all of them are even. 2A1, 2A2, something like that. All of them we know even, and we cannot use ones because we said 1, 1. And some of them is 4, so we can say A1 plus A2 and so on is what? 2. So it is equal to A2. Okay, because if you don't consider 2, if you divide by 2, then it will be 3 ones, 3 twos, like this. This one similarly will be A1. So A5 is A2 plus A1, which is what? A2 plus A1 is 2 plus 1, 3. Now let's check A2K is what by this idea. A2K, if you want to create 2K, because 2K is even, we don't have 1 or we have two ones, okay, or 0, 1. Then the rest are even numbers. 2A1. Sorry, here I've meant by A1 some weights. For example, let me write it as W1, W2, and something like that. Then W1 plus W2 equals 2. Here, you say, okay. Again, here, let me correct it. For example, 2W1 to 2W, for example, S equals what equals 2K. So W1 to WS equals K. So for this case, it is AK. The net rest is 2W1, for example, 2WS prime is 2K minus 2, this one, because we have two ones. So if we divide by 2, it is AK minus 1. So for A2K, it is AK plus AK minus 1. Now let's consider A2K plus 1. We're right. Okay, let me tell you something. Exactly like this, try to calculate A2K plus 1 first on your own. Okay, when it is 2K plus 1, number of ones will be what? 1 or 3. And here, sum of like this. If you do, sum will be what? Here, it will be 2K. So if you divide by 2, it will be AK. Here, it will be 2K minus 2. Because the whole weight is 2K plus 1, it will be 2K minus 2, it will be AK minus 1. So it is AK plus AK minus 1. Okay. Now we will prove, so for all these structures, for example, when you reach I7, I8, when you see something like this, for example, here, closed form, we can use induction, okay, in these types of problems to solve. So We found the form and on. If the form is similar to this, look here, we don't say that for m even it is for m odd. We found a formula that satisfies both of them, even and odd. Now we can use this formula. If we use induction, so A2k is what? A2k. Yeah, we want to prove that AM is m over 2 plus 1. A2k is AK plus AK minus 1. And at the end, I will tell you base case. We need which base cases. Okay, after solving the problem, you should pay attention to your proof and you will find out exactly you need which base cases. So AK is what? Is k over 2 plus 1. This one is what? K minus 1 over 2 plus. Okay, and we want to prove it is what? It is 2k over 2 is k plus 1. Now, here look, if you consider these two numbers, we know one of them is odd, one of them is even. So we can write it as k over 2 plus k minus 1 over 2. We know exactly one of them is odd, so we have 1 minus half. Plus 1 plus 1. We want to prove why it is k plus 1. So k over 2, k minus 1 over 2, minus 1 over 2, we can cancel these minus half with this. So k over 2 plus k over 2 is k plus this one, k plus 1. So we proved this. Now for 2k plus 1, with exactly same way, try to prove a2k plus 1 satisfy this. Try first on your own. Okay, now if we consider a2k plus 1, we know it is, we proved it is ak plus ak minus 1, which is k over 2 plus 1 plus k minus 1 over 2 plus 1, floor of it. Okay, so here it will be what? It will be, again, we know one of them is even, one of them is odd, so we can write it k over 2 plus k minus 1 over 2. Because of the one that is odd, we have negative 1 over 2 plus 1 plus 1. Negative 1 half, and 1 will be cancelled. It will be k plus 1. Okay. So if you use this formula, 2k plus 1 over 2 plus 1 is what? Is k plus 1. So it is correct. Okay. Wanted to see is it correct or not. Now, if we want to use base case, we know A0 is what? A1 is what? A1 is 1, A2 is 2. A1 is 1, A2 is 2. Okay, so for example, if you want to use A4, we should use A2. And for 2, you cannot use because you need A0. It's better to not use this. A3. A3, K is 1. A1 and A0. No, so we should write also A3. We proved it is what? 3 over 2 is 2. A4. For A4, K is 2. A2 plus A1. It is okay. For A5, K is 2. A2 plus A1. So these are our base cases, okay? This is the way that you will understand you should use which base cases. Okay, now that I've told you this important idea, in recursive sequence, we have two important ideas. One of them is this. Now we solve this BMO problem with exactly this idea. I want to solve one problem of IMO with exactly this idea, okay? And as I said, there are two important ideas in recursive sequence. One of them is this. If you want to learn the other idea or other ideas of, for example, other topics, As I said before, feel free to send message to my WhatsApp number in the description and comments. Okay, let's try the IMO problem. And sorry, I forgot. The previous problem says 2021. So the answer will be 2021 over 2 floor of that plus 1, which is 1010 plus 1, which is 1011. Okay? And the answer is this. Now, let's try this problem from IMO related to recursive sequence. So read the problem. Okay, important part of this problem is that when you place these weights, the right pan is never heavier than the left pan. Okay, so left hand is always greater than equal right hand. So if we didn't have this condition, how many ways are there without condition? Pause the video and try to find on your own. It is n factorial for the order times 2 to the n for each weight on left side or right side. Now, let's solve by this condition. I want to solve it as an. Again, look, I want to ask same question. N represents what? Idea 7, okay? Here, n represents what? We can say number of steps or number of weights. And if you consider both of them, for each of them, we'll reach a different solution, but our last answers are same. Let me tell you easier ones. If you wanted to solve with number of steps, feel free to send message to my WhatsApp number in the description comments. So here I say, okay, consider it as number of weights. Okay, now we consider, for example, first or last. So here we consider, or last weight, first weight. Okay, first weight is what? 2 to the 0. So if 2 to the 0 is in first step you want to place it, okay? Then it should be on which side? Left. One case, and the others will be an minus 1 because it has no effect on the others. If, for example, one side is greater, without 1 also, that side is greater, okay? Because if 1 plus 2 to the k1 to the, for example, kr is greater than 2 to the, for example, k prime 1 to 2 to the k prime s, which all of these k prime 1 to k prime s and k1 to k are, all of them are different and greater than equal 1, k the powers. Then if you remove 1, this inequality will be correct again, okay? Or if it is greater than equal, by removing this, it will be correct. Now, let me tell you other things, because let me tell you, the reason is what the maximum power, if you consider all these things, maximum ki is on this side, okay? And if you consider, for example, 2 to the x, if you add all powers less than 2 to the x to 2 to the 1 plus 2 to the 0, it will be 2 to the x minus 1, okay? And you can prove it on your own, it's not hard. Okay, so it is important that maximum power is on which side, and equality also doesn't hold. We can say it is strictly great. So in first step, it is this. If you place it in, for example, second step or third step, so we say consider others, an minus 1, so first weight, second, third to n minus 1. Now you can place first weight here in second step or third step or n minus first step, and for each of them on left hand or right hand, and it has no effect. So it will be 2 times n minus 1. Now, if we add, now try to add and try to simplify and find closed form of an on your own. Okay, so if you simplify an equals, if you factor from an minus 1, it's an minus 1, 1 plus 2n minus 2, which will be 2n minus 1, an minus 1. Again, also for this problem of IMO, we need to do what? We need to use telescoping rule, but here telescoping product. An over an minus 1 is what? 2n minus 1. An minus 1 over an minus 2 is what? Is 2 times n minus 1 minus 1, which is 2n minus 3. Up to a2 over a1 is what? It's 2 times 2, 4 minus 1, 3. So if you multiply all of them, an minus 1, this one will be cancelled. This one with next one, next numerator, and this one. So an over a1 is what? Is 3 times 5 times 2n minus 3 times 2n minus 1. Okay? So we have a1 is 1, obviously. It will be what? 1 times 3 times 5 times 2n minus 1. Also, we can write it in different form. We can, for example, add two even numbers, 3 times 4 times 5 times 2n minus 1 times 2n, and then divide it by these even numbers, which is 2 times 4 times 6 times 2n. Now, numerator is 2n factorial, denominator is, if you factor from all 2's, 2 to the n times n factorial. Okay, so for example, if you replace with 3 and with 3, or n with, yes, n with 2, we know a2 by this formula is 1 times 3, 3. If you replace here, it will be 4 factorial, 2 squared times 2 factorial, which is 6 over, is 24 over 8, which is 3. And you can check, for example, you can have 1 first, then 2, then it will be on left side, on left side. If we place 2 first, then 1, it will be on left side here, left side or right side, 3 cases. Also, you can check for A3, it will be 15, and you will see there are 15 cases, okay? So idea 8, for these types of problem, try to, let me see here, I've told you idea 7. Idea 8, when you look, it takes time, you've calculated all these things, maybe you have careless mistake. Try to check at the end, okay? It's so much important at the end. Okay. Now let me write some homeworks that you can solve by similar ideas. For this problem, we can call, so you can solve this one as homework 6. Try to focus on only part B. Okay, part A is related to invariant. In next videos, maybe we work on that, or if you want to learn completely invariant, also we have in BMO problems, BMO 1 problems invariant, also BMO 2 2023. There are some techniques, 3 important main techniques that you should learn. If you want to learn that, feel free to send message on WhatsApp number in the description comments. Part B is, you can solve it exactly with the ideas I've told you. Consider, for example, n represents what, and you can solve it is IMO problem 2019. Okay, if you want to solve more problems or want to learn more ideas, as I said before, feel free to send message to my WhatsApp number in the description comments. Okay, thanks for watching this video. Have a good day. Bye.